Question 1. Too careful analysis of student engagement during a hands-on training module. Instructor is Delgado noticed that only the top-performing students were participating, while others remained disengaged. She is preparing a new module to ensure all students, regardless of skill level, participate actively. Which of the following instructional adjustments best supports equitable engagement based on adult learning theory? A. Replace hands-on activities with lectures that simplify the content. B. Create tiered tasks that allow varying levels of student entry based on ability. C. Eliminate group activities to minimize peer dependence. D. Introduce mandatory quizzes to ensure focus before class begins. Answer. Correct answer. B. Explanation. Tiered tasks align with Noel's principles of andragogy by addressing diverse learner readiness and experience levels. This supports inclusive engagement while preserving rigor. Replacing hands-on with lectures diminishes experiential learning, key component of vocational education. Eliminating group activities. C. Ignores collaborative benefits. Quizzes. D. Assess preparation, not hands-on skill building. Reference. Noel's M.S. 1980. The Modern Practice of Adult Education. Question 2. In the context of servicing a commercial walk-in freezer using R404, a technician Mr. Coleman used the superheat method to determine refrigerant charge. However, the system uses the thermostatic expansion valve TSV. What is the most appropriate method for verifying proper refrigerant charge in this case? A. Check subcooling at the condenser outlet. B. Use system pressures alone. C. Observe frost buildup on suction line. D. Monitor evaporator temperature drop. Answer. Correct answer. A. Explanation. ESV systems maintain a fixed superheater, thus subcooling is the proper method for charging. The system pressures alone, B, are insufficient without corresponding temperature readings. Frost observation, C, may indicate undercharging but lacks precision. Temperature drop, D, only indirectly relates to charge. Reference, ECA Manual RS EPA Section 608 Guidelines. Question 3. When presented with a variable refrigerant flow system installation at a commercial high-rise, Instructor Mr. Patel is tasked with training technicians on proper commissioning. Which concept is most critical for technicians to understand during this phase? A. Matching indoor coil ratings to air. B. Static pressure testing across duct branches. C. Software configuration of refrigerant routing and address mapping. D. Seasonal adjustment of thermostat set points. Answer. Correct answer, C. Explanation. ERF systems rely on digital mapping of indoor units through proprietary software for accurate refrigerant routing and control. This process is essential for commissioning. Coil ratings they apply during design. Static pressure, B, is critical for ducted systems, but not VRF's priority. Thermostat set points, D, relate to usage, not commissioning. Reference, RA Standard 1230, in manufacturer commissioning protocols. Question 4. Based on the information in a psychrometric analysis of a high humidity space, the air leaving the evaporator coil is below the dew point. What type of heat is primarily being removed in this condition? A. Latent heat. B. Radiant heat. C. Sensible heat. D. Convective heat. Answer. Correct answer. A. Explanation. When air cools below its dew point, moisture condenses, releasing latent heat. This process is essential for dehumidification. Sensible heat, C, refers to temperature changes above dew point. Radiant, B, and convective, D, are modes of transfer, not heat types. Reference, ASHRAE Handbook, Fundamentals, Chapter 1, Psychrometrics. Question 5. The primary reason for oversizing residential AC units as observed by HVACR educators often stems from customer preferences and misconceptions. What is a major consequence of consistently oversizing systems when performing manual J calculations? A. Improved latent capacity. B. Reduced equipment cost. C. Short cycling and humidity control issues. D. Increased heat exchanger efficiency. Answer. Correct answer, C. Explanation. Oversized equipment short cycles, leading to insufficient moisture removal and inefficient operation. This undermines comfort and system longevity. Latent capacity, A, is reduced, not improved. Cost, B, typically increases. With larger units, heat exchanger efficiency, D, declines due to short run times. Reference, the CAM Annual J&S Guidelines. Question 6. As illustrated by a campus facility integrating multiple HVAC systems through a central building automation system, BAS Istanuen teaches students about control strategies, which control strategy minimizes simultaneous heating and cooling in multi-zone systems, A. Thermostatic cycling, B. Economizer operation, C. Deadband temperature control, D. Modulating airflow based on static pressure. Answer. Correct answer, C. Explanation. Deadband control maintains a neutral zone between heating and cooling set points, preventing both systems from activating simultaneously. Thermostatic cycling, A. Causes more frequent switching. Economizers, B. Manage ventilation but not zone conflict. Static pressure modulation, D. Optimizes fan performance, not temperature conflict. Reference the ASHRAE Guideline 132015 about standard. Question 7. In light of recent developments, is Ortega trains apprentices on compliance with Section 608 of the Clean Air Act. During a recovery job on a large low-pressure chiller, a technician vents 5 cig of refrigerant to complete the recovery. What legal consequence could this lead to? A. Acceptable if done under 90% recovery. B. Minor infraction, no legal consequence. C. Violation subject to EPA penalties up to $44,539 per day. D. Permissible if documented in service records. Answer. Correct answer, C. Explanation. Ventilation of refrigerant, even low-pressure types, is federal violation under EPA 608. Fines up to $44,539 day per violation may apply. There is no minor infraction cause, B, and documentation, D, doesn't grant permission. 90% recovery, A, doesn't allow intentional venting. Reference 40 CFR Part 82, Subpart F. Question 8. While examining HVACR course content alignment with student assessment outcomes, Mr. Simmons finds high failure rates in electrical troubleshooting. What is the best instructional design response based on backward curriculum design? A. Add more advanced theory modules before troubleshooting. B. Remove lab work and focus on written exams. C. Redesign the course to first teach diagnostics aligned to final assessment tasks. D. Integrate HVAC history and terminology into more modules. Answer. Correct answer, C. Explanation. Backward design starts with desired outcomes, A. Troubleshooting proficiency, and builds instruction to reach that goal. Adding theory, A, may increase complexity without skills. Removing labs, B, removes hands-on practice. HVAC history, D, isn't directly linked to troubleshooting competency. Reference Wiggins and McTighe, Understanding by Design. Question 9. Throughout the course of a copper piping installation, Instructor Mr. Lewis observes a student overheating joints, resulting in internal scaling. What is the most critical consequence of this on system operation? A. Improved refrigerant flow from smoother joints. B. Reduced oil return and potential compressor failure. C. Higher system superheat and lower SEER rating. D. Enhanced thermal conductivity of the joint. Answer. Correct answer, B. Explanation. Excess flux or overheating leads to carbon scale and metal oxides, which restrict oil return, risking compressor damage. It does not improve a flow or D. Conductivity. Superheat, C. May change, but oil return is the critical failure point. Reference ASE's brazing standards, the HVAC Excellence Instructional Guidelines. Question 10. Examining the consequences of purely multiple-choice testing in HVACR instruction, Mr. Wallace notices students struggling with practical performance. What best supports assessment of actual HVACR skills? A. Increase frequency of theoretical quizzes. B. Use oral questioning to verify memorization. C. Incorporate performance-based assessments using task checklists. D. Rely on peer reviews of classroom participation. Answer. Correct answer, C. Explanation. Performance-based assessments with structured rubrics or checklists evaluate hands-on skill application, aligning with industry certification requirements. Theoretical quizzes, they and oral questions. B. Test recall, not skill. Peer reviews. D. Lack of objectivity and reliability in technical assessment. Reference NC-SIR Instructor Certification Training Program by Ethical Education Standards by ESCO. Question 11. With the advent of higher ventilation requirements in commercial buildings, Mr. Granger is instructing students on the application of demand-controlled ventilation DCV using code sensors. Student asks what would happen if DCV systems were not properly calibrated. What is the most probable consequence? A. Excess outside air causing higher energy use. B. Reduced static pressure leading to fan shutdown. C. Compressor overloading from refrigerant migration. D. Short cycling due to oversized equipment. Answer. Correct answer. A. Explanation. Uncalibrated co-sensors may read high levels even in well-ventilated spaces, causing the system to increase outdoor air unnecessarily. This leads to overventilation, increased load on conditioning equipment, and energy waste. Static pressure. B. Relates to duct issues. Compressor problems. C. And equipment sizing. D. Are unrelated. Reference ASHRAE Standard 62.1 2022 Building Init. Codes programmed. Question 12. The underlying principle of electrical fault analysis in HVACR systems teaches that high resistance in a motor winding can go unnoticed under no-load testing. During a troubleshooting lab, Carter wants to demonstrate this concept. Which test would best reveal a fault under operational load? A. Insulation resistance test with a megameter. B. Voltage drop measurement across windings under load. C. Continuity check using an ohmmeter. D. Ground to frame resistance test. Answer. Correct answer. B. Explanation. Voltage drop testing under load shows how resistance affects circuit performance in real time. Megameters. A. Check insulation, not operational resistance. Continuity. C. Checks only for open circuits. Ground resistance. D. Checks for short circuits but not load faults. Reference NFPA 7-Net maintenance testing specifications. Question 13. Given the circumstances in a supermarket's walk-in cooler where products are freezing despite the box temperature reading 38°, Instructor is morale's challenges students to explain the discrepancy. What is the most likely cause? A. Defrost cycle too short. B. Faulty evaporator fan relay. C. Malfunctioning sensing bulb placement on the TSSV. D. Oversized compressor reducing cycle duration. Answer. Correct answer. C. Explanation. A mislocated sensing bulb may cause the TXV to flood the coil, dropping surface temperatures below freezing while ambient air remains above freezing. This leads to localized freezing of products. Defrost issues. A. Fan faults. B. And compressor oversizing. D. Are secondary possibilities. Reference HVACR Refrigeration Manual, Emerson SSV Best Practices. Question 14. From a practical standpoint, Mr. Hawkins, an instructor at a technical college, hears a student using derogatory language during lab time. The student insists it was just a joke. What is the most professionally appropriate instructor response? A. Ignore it if no one complained. B. Use humor to diffuse tension. C. Stop the activity and address the behavior privately. D. Call out the student in front of the class as a warning. Answer. Correct answer. C. Explanation. Professional ethics and instructional standards require maintaining a respectful learning environment. Private correction maintains dignity and reinforces behavioral expectations. Ignoring A. or joking. B. Downplays the issue. Public reprimand. D. May cause embarrassment or escalate the situation. Reference HVAC Excellence Instructor Code of Conduct. Italia Romana Reigning Guidance. Question 15. In comparison with a standard vapor compression cycle, an HVACR instructor is explaining the efficiency of a heat pump in heating mode under low outdoor temperatures. What principle best explains why the coefficient of performance, COP, decreases as outdoor air cools? A. Less heat is absorbed due to lower temperature differential. B. Compressor wear increases with runtime. C. Defrost cycles increase total humidity. D. Expansion valve failure becomes more likely. Answer. Correct answer. A. Explanation. Lower outdoor air temperatures reduce the available heat the refrigerant can absorb in the evaporator, reducing efficiency. COP. Compressor wear. B. Is not a thermodynamic factor. Defrost and TXV failures. C. D. May occur, but are not the core principle here. Reference the ASHRAE Handbook. HVAC systems and equipment. The thermodynamic COP formulas. Question 16. To better understand alignment between assessments and objectives, Instructor is bent and is reviewing a unit on residential gas furnaces. Despite strong lecture attendance, students score poorly on ignition sequence troubleshooting. What should she revise first? A. Increase the number of PowerPoint slides. B. Add more reading from the codebook. C. Integrate lab tasks that match assessment outcomes. D. Extend class time by 15 minutes. Answer. Correct answer. C. Explanation. Best practices in curriculum development emphasize alignment between instructional tasks and assessments. Practical skill gaps suggest a need for more aligned hands-on learning. Slides A and readings. B. May support theory, but not skill. Time extension. D. Doesn't address misalignment. Reference Bloom's Taxonomy, ITFAQ Excellence Curriculum Alignment Guide. Question 17. By evaluating multiple rooftop package units during EEVIT, Mr. Alvarez finds recurring blower belt wear every 30 days despite proper tensioning. What is the most likely root cause? A. Misaligned pulleys causing uneven wear. B. Use of EVFDS at maximum frequency. C. Inadequate compressor oil levels. D. Undersized return ductwork. Answer. Correct answer. A. Explanation. Even when tensioned properly, pulley misalignment causes belts to wear rapidly due to shear force. VFDS. B. Impact motors, not belts. Compressor oil. C. Relates to refrigerant circuits. Return ductwork. D. Impacts airflow, not mechanical wear. Reference NEB Preventive Maintenance Standards. The SMACA HVAC Duct Design Manual. Question 18. The growing trend in refrigerant handling has introduced mildly flammable refrigerants in HVACR systems. During safety training, Fox emphasizes changes in recovery practices. Which safety measure is newly required with our refrigerants? A. Use of Class B fire extinguisher nearby. B. Venting to outdoors is now acceptable. C. Spark-proof recovery units and leak detection. D. Mandatory double evacuation for all units. Answer. Correct answer. C. Explanation. Our refrigerants are classified as slightly flammable. Recovery units must be rated for use with flammable refrigerants, and leak detectors must comply with all 603-35240. Fire extinguishers are general but not new. Venting B remains illegal under EPA 608. Double evacuation D is not universally required. Reference all 603-5240. ASHRAE Standard 15.2 2022 EPA SNAP rules. Question 19. One might argue that inverter-driven compressors are harder to troubleshoot than traditional single-stage compressors. Instructor is Rivera wants students to understand the most reliable approach to diagnosing a non-starting inverter compressor. Which steps should be taken first? A. Replace the inverter board immediately. B. Test incoming power and board output voltages. C. Assume the compressor is locked and replace it. D. Disconnect the board and run in bypass mode. Answer. Correct answer. B. Explanation. Inverter compressors are controlled electronically, so power and signal checks are the starting point. Replacing components without testing. A. C. is poor practice. Running in bypass mode. D. Isn't always possible or safe without manufacturer tools. Reference OEM troubleshooting protocols. Daikin Mitsubishi Innate Specialty Guidelines. Question 20. From multiple perspectives, Mr. Langdon designs HVACR lessons for veterans transitioning into the industry. He observes they struggle with digital simulations. Based on adult learning theory, what adjustments should he prioritize? A. Increase lecture time to explain tools thoroughly. B. Use simulation tutorials with real-world tie-ins. C. Reduce digital tools and use printed worksheets. D. Assign simulations as homework to learn independently. Answer. Correct answer. B. Explanation. Adults benefit from contextualized learning. Simulation tutorials that connect virtual experience to field scenarios increase motivation and transferability. Longer lectures. A. Reduce engagement. Avoiding technology. C. Limits development. Independent simulation. D. May cause frustration without scaffolding. Reference Knowles Andragogy Model. ETFAQR Learning Design Guidelines. Question 21. The implications of improper slope on horizontal refrigerant suction lines were observed by instructor Mr. Thomason during a student lab. One group routed a suction line flat across a 20-foot horizontal span. What is the most critical concern with this configuration? A. Overheating of the liquid line. B. Insufficient oil return to the compressor. C. Reduced velocity causing high discharge pressure. D. Moisture migration toward the expansion device. Answer. Correct answer, B. Explanation. Suction lines must be pitched toward the compressor, typically 1 blow per 10 feet, to facilitate oil return. Flat suction lines risk oil logging, which can lead to compressor failure. Overheating A concerns liquid lines. High discharge C is not caused by horizontal suction routing. Moisture migration D is unrelated. Reference a CAM manual D. ASHRAE Refrigeration Handbook. Question 22. Considering the evidences, Zhao implements a flipped classroom for HVACR troubleshooting. She assigns videos and simulations as homework and uses class time for diagnosis activities. Which benefit aligns most with this approach? A. Students memorize code requirements faster. B. Passive learners become less dependent on peer instruction. C. Learners can apply concepts through active engagement during class. D. Quizzes become easier to grade. Answer. Correct answer, C. Explanation. Flipped classrooms prioritize application and problem solving during in-class time. This promotes deeper understanding of diagnostic processes. Memorization A is not a primary goal. Passive learners B still need facilitation. Grading quizzes D is unrelated to learning design. Reference Bergman and Sam's 2012 Flip Your Classroom Etika Education Instructional Guide. Question 23. To what degree does failing to label recovered refrigerant containers violate EPA Section 608 regulations? During an instructional lab, Mr. Bennett notices recovered R22 stored in an unlabeled grey cylinder. What is the potential outcome? A. Acceptable as long as it is stored indoors. B. Requires technician to log the recovery date only. C. Considered a violation that may result in EPA fines. D. Legal only if the refrigerant is below 10 pounds. Answer. Correct answer, C. Explanation. Under EPA 608-40 CFR Part 82, recovered refrigerant must be stored in approved, clearly labeled containers indicating refrigerant type and status e.g. used R22. Recovered. Failing to do so is compliance violation. Quantity D or location A doesn't negate the labeling requirement. Reference EPA 608 Technician Certification Rules, 40 CFRS 154. Question 24. Through the lens of high-efficiency gas furnace operation, instructor Mr. Evans teaches students about secondary heat exchangers. A student incorrectly states that they are used to reheat supply air. What is their actual purpose? A. They absorb radiant heat from the combustion chamber. B. They capture flue gas heat to increase combustion air pressure. C. They extract latent heat from combustion gases for added efficiency. D. They provide zoning separation for multi-stage burners. Answer. Correct answer, C. Explanation. Secondary heat exchangers in condensing furnaces reclaim latent heat from water vapor in flue gases, boosting efficiency above 90%. Radiant heat A is absorbed by primary exchangers. Zoning D and air pressure B are unrelated functions. Reference Doe Furnace Efficiency Standards, the ARI Gas Furnace Handbook. Question 25. From a historical standpoint, split-phase motors are commonly used in HVAC applications. Instructor Grant asks her students why. A capacitor start induction run motor is preferable for compressor duty, which answer best explains A. It prevents rotor slip under full load. B. It enables high starting torque necessary for compressors. C. It reduces power factor fluctuations. D. It limits inductive kickback from the contactor. Answer. Correct answer, B. Explanation. Compressors require high starting torque, especially under load. Capacitor start motors provide this, making them suitable for HVACR applications. Rotor slip A is inherent to induction motors. Power factor C and inductive kickback D are secondary considerations. Reference NEMA MG1 standard. CISA electrical manual. Question 26. A critical examination of the school HVAC upgrade reveals that manual J-load calculations weren't revised for new building insulation. Instructor ISTA Randa challenges students to determine the most likely sizing issue that will arise. A. Oversized ductwork reducing air velocity. B. Oversized cooling system causing short cycling. C. Undersized blower motor due to ESP increase. D. Undersized refrigerant lines from line length. Answer. Correct answer. B. Explanation. Improved insulation reduces heat load. If sizing isn't recalculated, the cooling system may be oversized, leading to short cycling and poor dehumidification. Ducts A, blowers C, and line sizing D are related but secondary to the primary mismatch. Reference: a CAM Manual J and S HRConquer load calculation guidelines. Question 27. With respect to mentoring new instructors, ISTA Connolly's training is peer to handle student resistance during lab work. What approach is most aligned with effective mentorship? A. Provide a strict script and require verbatim teaching. B. Allow the new instructor to fail for learning purposes. C. Offer feedback and model appropriate facilitation techniques. D. Let senior students lead the lab to reduce pressure. Answer. Correct answer. C. Explanation. Effective mentorship includes modeling behavior and providing constructive feedback. Scripts A. Restrict adaptability, allowing failure. B. Without support risks morale. Delegating to students. D. Abdicates the teaching role. Reference: AST Mentoring Handbook, HVAC Excellence Instructor Competency Model. Question 20. Upon closer examination, instructor Dias finds that a heat pump in heating mode has high suction pressure and low superheat. What is the most likely cause of this condition? A. Defective reversing valve stuck in cooling. B. Overfeeding EXP due to stuck internal port. C. Undersized indoor blower motor. D. Cracked heat exchanger introducing flue gases. Answer. Correct answer. B. Explanation. Low superheat with high suction indicates excess refrigerant entering the evaporator. Likely stuck or failed EXP reversing valve fault. A. Would cause incorrect mode operation, not this pressure superheat combo. The blower C and heat exchanger D are unrelated in this scenario. Reference: HVACR troubleshooting guide says Danfoss TSV diagnostics. Question 29. Looking at the data on student progress within a learning management system, LMS ISIATE notices many students skip HVAC electrical theory modules. What LMS feature could best improve participation? A. Locking sequential progression until completion. B. Replacing electrical content with simulations only. C. Removing assessments to reduce pressure. D. Offering completion certificates for each submodule. Answer. Correct answer. A. Explanation. Sequencing content ensures learners complete foundational material before moving on. Simulations alone. B. Can lack depth. Removing assessments. C. Reduces accountability. Certificates. D. Are motivational but don't ensure mastery. Reference: SCORM compliance standards. HVAC Excellence, a learning framework. Question 30. Throughout the course of a multi-split mini-split system class, ISTA explains to students why simultaneous heating and cooling is possible. A student asks, what component allows for this? A. Fixed orifice metering device. B. Dual-zone programmable thermostat. C. Branch selector unit or three-pipe system. D. Parallel condenser coils. Answer. Correct answer. C. Explanation. Simultaneous heating and cooling in multi-split systems relies on branch selector units or three-pipe systems, allowing refrigerant to be routed for heating or cooling independently. Orifices A. Thermostats. B. And condensers. D. Do not manage zoning refrigerant flow. Reference: Manufacturer ERF training manuals, Mitsubishi Daikin I-1230 standard.